All right, so yesterday we talked about quadratics and inequalities, right? So we said we're going to get everything to one side so that it has a relationship either less than or greater than whatever to 0. And then we're going to factor where we need to, use the quadratic formula where we need to, use those two answers to set up our test points, and then check based on the pattern that we know like usually works, okay? So for number 1, it's already got all the numbers to one side except for 0. So I want to see if I can factor this. If I multiply 2 times -3, I get -6. Are there factors of -6 that sum to -5? Yes. What are they?
-6 and 1.
Good. -6, +1. So I get 2x squared minus 6x. Well, let me write it first without the parentheses, and then we'll group it. Plus 1x minus 3, and then group it. And from the first set of parentheses, I can take a 2x, x minus 3. Second set of parentheses, just take out a +1, x minus 3. And I get x minus 3 and 2x plus 1. Set them each equal to 0 to get our roots, which are 3 and -1/2. Then we set up our number line, -1/2 and 3. So because from the beginning, this is a less than statement, I assume it's going to be a what? And. Good, which means shade in between. So let's take that easy point, which is 0, and plug it in to see if it works. 2 times 0 squared minus 5 times 0 minus 3 is less than 0. This goes away and I get -3 is less than 0. True statement. So I put a parentheses on the -1/2, the parentheses on the 3, and I shade in between in interval notation, which is how your quiz will ask you to enter these answers. Or how the test, will ask you to answer these answers. It's parentheses, -1/2, comma 3, close the parentheses, no spaces. Questions on that one? Okay, go to 2. This time it's not already equal to 0. I got to move that 121 over. So x squared minus 121 is less than 0. Factor that difference of 2 squares, x plus 11 and x minus 11. And I get -11 and +11. Set up my number line. It's a less than, which means we think it's going to be and, which would be in between here. So I'm going to plug in 0. And I can plug it into the original or to the one that I set less than 0. It doesn't matter where you plug it in. If I did it in the beginning, I'd get 0 squared is less than 121, and 0 is less than 121, so we're right. Parentheses on these, shaded in between, and my interval notation is -11 to 11 with a parentheses on both. Question on that one? Okay, then comes number 3. So same exact type of question here. Subtract the 4, but this time it's greater than or equal to. So when I factor this, difference of 2 squares again, I get -2, +2. But because it's a greater than, we think it's an or. So think of the rows, the oars on a boat, point out, right? So I want to plug in something less than -3 and plug in something, less than -2, and something greater than +2. And again, I can plug it into the original or to the one that I moved the 4 over. I'd get -3 squared is greater than or equal to 4. 9 is greater than or equal to 4, so that works. And then I get 3 squared is greater than or equal to 4. 9 is greater than 4. Again, that works. This time we give them brackets and point the arrows out. So my interval notation here is -infinity to -2 with a bracket on the 2, union +2 with a bracket on the 2 pointing to infinity.
On the website, it'll let me put the comma.
Yeah, it'll let you put a comma, and same for the Canvas quiz on Tuesday when you take your test. I gave you the option of a U, a comma, or a semicolon, okay? But you have to do it in words. -infinity, -2, bracket, again, U, comma, semicolon, 2, bracket 2, and then the word infinity. You're actually going to type your answers in anyway, so you can use the paper to do your scrap, but you're going to answer it probably. I mean, I'll let you answer it on paper, and then if you've got the time, go back and type it in. So when you type it in, it would be like that. Yeah. I have paper for you, but if you finish, to make my life easier, I'm going to also have you type your answers in. Yeah. Okay, last one. I got to move the 5 over. So x squared minus 2x minus 5 is greater than 0. There are no factors of negative 5 that sum to negative 2. So we do the quadratic formula. A is 1. B is negative 2. C is negative 5. And I get negative 2, so it's 2, plus and minus the square root of negative 2 squared minus 4 times A times C, which is negative 5, all over 2 times A. 2 plus and minus the square root of 4. Negative 4 times 1 is negative 4, times negative 5 is positive 20 over 2. 2 plus and minus the square root of 24 over 2. 2 plus and minus, this is 4 and 6, so 2 root 6 over 2. Simplify, and I get 1 plus and minus square root 6. So that, sorry, I shouldn't have circled it. That's not the answer. That's where my test points are. So keep in mind that this is now 1 minus square root 6, because that would be smaller than 1 plus square root 6. Now to figure out that range there, you could totally approximate, like root 6 is in between root 4 and root 9, right? So I know maybe root 6 is like a 2.3, 2.4, something like that. So I would get 1 minus 2.3, which is like a negative 1.3, and 1 plus 2.3, which is like a 3.3. The only reason I need that is to figure out what would be a point in between there. It's obviously 0. Because this is a greater than statement. I think it's an or, so I point out. So I want something that is smaller than negative 1.3, let's say negative 2, something bigger than 3.3, let's say 4, and we plug those in. And again, you can plug them into the very beginning or to the one that we shifted over. Yep. No. Yeah.
So it would be like x is greater than 1 plus or minus square root 6.
You have to split those.
Okay.
Yeah, so because we're setting up those test points, you have to split the plus and minus, yeah. So I have to plug in negative 2. So negative 2 squared minus 2 times negative 2 minus 5 is greater than 0. And then I'm going to plug in positive 4. 4 squared minus 2 times 4 minus 5 greater than 0. So 4 plus 4 minus 5 is 8 minus 5, that's 3, which is greater than 0. 16 minus 8 minus 5, 8 minus 5, which is 3, also is greater than 0.
Wait, how would it still be 4 squared, right? Negative 2 squared just be 4? Or are you testing, you were testing on a different one. I thought you were
Right, no, I did both. I did one to the left and one to the right.
I thought you were like solving the same.
No. So then I know it's like the or is on a boat. It points out parentheses because it's not an or equal to statement. And my interval notation is negative infinity to 1 minus root 6 with a parentheses union 1 plus root 6 to positive infinity. Questions on that one? So that's the tricky one because it's got the root that's not a perfect square, so it's harder to find those points. Okay, but the process is exactly the same. You're going to approximate what that root is, figure out what would fall between or outside, and then plug it in. So there is one like that on your test. Okay. All right, so let's do notes. We'll flip-flop. We'll do the notes, and then we'll come back to questions. We should be able to get to them because there's not a ton of slides, but I do want to make sure we get through all of them. So chapter 1, section 8b is continuing with inequalities, okay? But now we've got rational inequalities, which means fractions. Okay? We've done rational equations, we've done rational inequalities. Now we're doing we did rational equations with just like numbers on the bottom. Then we did rational equations where you had a factor in the bottom. Now you're doing them with inequalities. So we start the same way. We have to get the equation is less than or greater than or less than or equal to or greater than or equal to 0. I have to isolate 0 on the other side of the equation. Then combine your terms so there's just one fraction. So if I had two fractions, I have to combine them into one. Once you get one fraction, instead of doing test points by factoring and getting 2, we actually do test points by the numerator and the denominator. So we set the numerator equal to 0, we set the denominator equal to 0. Those are going to be the points we plot on our number line. And then we test points just like we did with quadratic, okay? So the difference is how we get the points this time. All right, so actually I'm going to do 2 first and then I'll go back to 1, okay? So 2 is already got 0 on the side by itself, right? So we don't have to move anything. There's already only one fraction on the left, right? So all I have to do here is set these each equal to 0, and I'd get -1 and +4. Then I set up my number line, -1, +4. Now the rules of the greater than and less than, the little tricks, do not apply to rational, which means we've got to test points, okay? So I'm going to test a point that is less than -1, like -2. I'm going to test a point that falls in between, which would be 0. And I'm going to test a point that is bigger than 4, which is 5. And I'm plugging it back in here. So -2 plus 1 over -2 minus 4, greater than 0. 0 plus 1 over 0 minus 4, greater than 0. And 5 plus 1 over 5 minus 4, greater than 0. Let's see what works. The first one, I get -1 over -6, which is 1/6. That is greater than 0. The second one, I get 1 over -4. That is not greater than 0. The last one, I get 4 over 1. That is greater than 0. So now I know it's my OR, okay? It's like the ORs that point out. So I get a parentheses on the -1, point it left, and a parentheses on the 4, point it right. -infinity to -1, 4 to +infinity.
It doesn't change the, oh wait, it doesn't change the answer, but wouldn't it be 6 is greater than 0 for the third trial?
Oh, because it's 4. Yeah, this is 6. Thank you. Yeah, luckily it doesn't change it, right? 5 plus 1 should have been 6. I did 4, 5 minus 1. So the pattern for these, there are exceptions, but most of them should still be every other. It should still be in between, or it should still be out. It's just that the rules don't always apply. I can't always look up here and say that's greater, so it's an or statement. It doesn't work that way, okay? Sometimes it does, but sometimes it doesn't, so you don't you can't use that. Yep.
I have a question. When you're writing, like, I don't know what you call it.
Interval notation?
Yeah, the interval notation.
Mhm.
No matter what order you put, like.
Has to be smallest to largest.
But the infinities and the positives, that matters?
Yep, because negative infinity is the smallest thing that has to get written first.
Okay.
So it's always from smallest to largest. Good question. Always, always, always smallest to largest. All right, now go back up to number 1. And why did I skip it? Because it's not 0, right? So I have to move 1 to the left side. So I would get 5 over x plus 4 minus 1 is greater than or equal to 0. That was the first step. The second step said I have to get that into one fraction. I can't have 2 separate parts. So I have to give 1 over 1. The denominator, that would be x plus 4. And x plus 4, which means I'd get 5 over x plus 4 minus 1 times x plus 4, which is x plus 4, over x plus 4. So I had to change 1 so it had x plus 4 as its denominator, which is x plus 4 over x plus 4. Now combine them into one fraction. So 5 minus, and that minus goes to both, minus x minus 4 over x plus 4. And I get 5 minus 4, which is 1 minus x over x plus 4. Now I'm where I need to be to get my test points because I have one fraction and it's not equal to, but greater than or equal to 0. So now I split these. Numerator 1 minus x equals 0. Denominator x plus 4 equals 0. Add the x here and I get 1 equals x. Subtract the 4 here and I get x equals negative 4. Now my number line. And my test points. Plug in something less than negative 4, like negative 5. Something in between, like 0. Bigger than 1, like 2. Now you can plug it into the original, or you can plug it into the one that you set greater than or equal to 0. The benefit of the original is I know that it's right, but it doesn't really matter. So if I did 5 over negative 5 plus 4 is greater than or equal to 1, and then I'm going to do 5 over 0 plus 4 is greater than or equal to 1, and then I'm going to do 5 over 2 plus 4 is greater than or equal to 1. So I get 5 over negative 1. Negative 5 is not greater than or equal to 1. I get 5 over 4 is greater than or equal to 1. That's 1 1/4, so it is greater than or equal to 1. And I get 5 over 6 is not greater than or equal to 1. So I get the in between. You with me so far? So here's something you have to be so very careful of. Because of this sign, the greater than or equal to 0, what would you normally put on those points? Parentheses or brackets? Brackets. I would normally do this, right? And shade in between. But we have a domain restriction. Remember those extraneous roots you had to check for? Same case. If you have a variable in the denominator, I have to make sure that whatever that is can't get a bracket. So if I set that equal to 0, x cannot equal negative 4. It would make this whole thing undefined. So the positive 1 can keep the bracket, but the negative 4 has to change to a parentheses. So whatever would make the denominator 0 has to get a parentheses, even if my question has an or equal to in it.
Wait, can you explain that again?
So normally, because of this or equal to, you would put brackets on both, right? But if let's say I go back and I want to check this answer. The way that the bracket is saying you can use negative 4 as an answer. If I plug negative 4 into this x, my denominator is 0 and my whole function's undefined. So what you want to do is, if it's greater than or equal to, or less than or equal to, because if it was greater than or less than, it doesn't matter, it's already a parentheses. But if my initial question has an or equal to in it, then you have to say what would make my denominator 0, and whatever number that is has to change to a parentheses. Does that make sense? Yeah. Okay, so my answer here is not going to be brackets on both. It's going to be a parentheses on the negative 4 and a bracket on the 1.
So like if that was a plus 2, it could be a negative 2.
Correct. Yep. Only if it's or equal to. If it was just greater than or less than, it's already a parentheses. I don't have to worry about it. But if it's an or equal to, I have to make sure that that bracket gets changed to the parentheses on whatever would make the bottom 0, which is going to be one of your roots. Questions so far? Everybody good from home? All right. Number 3. What's step 1?
Subtract 4.
Good. I got to move the 4 to the left side, so I'm going to subtract it. 2x minus 1 over 3x plus 4 minus 4 is less than 0. Now I need 4 over 1 to become something over 3x plus 4. So I have to multiply that 4 by 3x plus 4. And I get 12x plus 16. and it's a minus in between, so it's 12x plus 16 over 3x plus 4. And then I distribute that minus. So 2x minus 1 minus 12x minus 16 all over 3x plus 4. Combine your like terms in your numerator. Positive 2, negative 12 is negative 10x. Negative 1, negative 16 minus 17 over 3x plus 4. All of this is less than 0. Okay. Now I get my test points. So I want to do negative 10x minus 17 equals 0 and 3x plus 4 equals 0. Add the 17.
How is it equal to 0 not less than 0?
When we get our test points, we set it equal to 0. Yep. And I get x equals negative 17 over 10, which you can rewrite as negative 1 and 7/10 if it helps you with like figuring out the numbers. And then 3x equals negative 4 and x equals negative 4/3, which again can be written as negative 1 and 1/3 if it helps you set up your number line. Now these two things are super close to each other, which is going to make it really difficult to pick the point in between it. Okay? When it's a scenario like this, I would just recommend picking the points outside, seeing if they work. If they work, then you're good. If they don't work, then you know it falls in the middle. Okay? But those 2 points are really close together. Like if I compare negative, I would change them so they had the same denominator and find the point in between. These two are really close together. So pick something that's less than negative 1 and 7/10, like negative 2, and something that's bigger than negative 1 and 1/3, like 1 or negative 1. Doesn't matter what you pick, as long as it's bigger. And then plug it in. So I'm going to plug it back into the original. 2, negative 2 minus 1 over 3, negative 2 plus 4, less than 4. And 2 times 1 minus 1 over 3 times 1 plus 4, less than 4. So I get negative 4 minus 1 over negative 6 plus 4, negative 5 over negative 2, which is 5/2. That is less than 4. And then 2 minus 1 over 3 plus 4 is 1 over 7. That is also less than 4. So because it's less than and not less than or equal to, I put the parentheses and I point my arrows out. And my interval notation would be negative infinity to the negative. And on your test, it's going to have you write it in as improper. So it would be 17, negative 17/10. And then negative 4/3, positive infinity. So again, if the numbers are really close together like that, feel free to just do check the other ones. Because remember, it's going to happen every other pattern. It's either going to be the inside or the outside.
So you won't ever get both?
The only time that it ever changes if we get a repeated root or we have 3 numbers, which is not going to happen with these fractions.
You ever have like both where it's the outside and the
No.
inside?
Like an all real number scenario? No, because it's not like an absolute value here. Yeah.
If one of them, if you think it's pointing outside and one of them doesn't work, do you have to check the other one?
No, but if it was a test, I'd double check to be sure. Yeah, like if it's homework, not a big deal, but obviously test, I would double check. All right, yep.
What's the rule like you see here, like when you like are multiplying, like when you subtracted the 4 and then you like multiplying it through, you have to give a minus to both? Is that what it is?
Yeah,
So
because this minus is going to this entire fraction, right? So it's got to go to both the terms in the numerator.
you distribute the minus through and then you multiply by the 2x minus 1.
Distribute the minus,
Like
make it negative 4 and then multiply, is that what you're saying?
no, like if you put like negative 12x minus
16.
I meant from the top one. Like you make it positive 4?
Here?
No. Like when you're multiplying, like when you're subtracting it, you have to make it a negative 4, right?
Oh, because you have moved the 4 from the right side to the left side. If it was a negative 4 on the other side, I would have added it. But because it's a positive, this one you mean? Like from here to get to here? Is that the step you're talking about?
After you do that.
After you do that, when you want to change, you can make it negative 4. It just would then be a plus the negative 4. So then the negative 4 gets multiplied by both the 3x and the 4. You could do that. Then it would be plus whatever you get from that. So you just can't have a minus there and a minus on the 4. You got to keep it one place or the other. Does that answer your question? Yeah. Okay, good. All right, try number 4. Try and see how far you can get. All right, so you should have moved the 2, changed the 2 so that it has 5 minus 3x as its denominator. From there, you get 6 minus 10 plus 6x because the negative's got to go to both. I get negative 4 plus 6x over 5 minus 3x, which means my 2 roots are 4/6, which becomes 2/3, has to get simplified, and then 5/3 or 1 2/3. When you set up your test points, I plug in something less than 2/3, which I plugged in 0, something in between 2/3 and 5/3, which I plugged in 1, and bigger than 5/3, I plugged in 2. The outer 2 worked. This case is that special case because it was or equal to at the beginning. Whatever root makes the 0 in the denominator, which was the 5/3, has to get the parentheses instead of the bracket. So I get negative infinity to 2/3 bracket, union 5/3 to positive infinity. Questions? Yep.
So like if you were checking to see if like you can still use a bracket, you would have to like put 5x.
Whatever the denominator is, whatever, go back to that denominator, whatever set made that 0 is what has to get the parentheses. Which you already found it, right? Because we already solved it. The denominator will always be that. So even after we combine it into 1, the denominator is always that 5x minus 3.
Like what number would you like not be allowed?
This one, 5 over 3. Because that came from the denominator, right? This came from the denominator. Yeah. Questions? Yeah. Because if I plug 5/3 in, I get a 0 in the denominator and it makes it undefined.
So we have to check it?
You have not check it, just go back to your question. Is it an or equal to? If it's an or equal to this, if that's an or equal to, then whatever makes the bottom 0, which I worked out over here, has to get a parentheses and not a bracket.
Yes, I'm saying, so you do have to like check it like that to work it out in order to.
Yeah, well, that you have to get your test point. You already did that work.
Oh.
You'll always already do the work. You just got to figure out which one came from like the numerator and which one came from the denominator. The denominator one has to get the parentheses.
Okay. Can
Yep.
you figure out real quick so
Sure.
I can do the infinity, right?
Interval notation?
Yes.
Yeah. And again, remember that like it's going to ask you to keep it simplified, so it had to be the 2/3, not the 4/6. But also improper, so 5/3 would be the correct answer, not 1 2/3.
Would you give us like partial credit if we forgot to not
Yeah.
do it like
Yeah.
something?
Yeah. I imagine I'll be giving partial credit on those that forget the parentheses too. So, yeah. All right, number 5. So it gets a little bit shakier because now we've got a denominator on the other side as well, right? So I'm going to move this over. -5 over 3x plus 2 minus 5 over x is greater than or equal to 0. Now I have to give my denominator the same, but it is a combination of the two, x and 3x plus 2. Which means the first fraction is going to have to multiply by x, and the second by 3x plus 2. So I get -5x. This minus goes to both the 15x and the 10. So distribute -5 to 3x plus 2 over my denominator's x and 3x plus 2. Greater than or equal to 0. Combine my like terms in my numerator, -20x minus 10 over x times 3x plus 2. Greater than or equal to 0. So now my numerator set equal to 0 just has 1 point, but my denominator, which is already factored and I don't want to distribute it because I end up just factoring it again, is going to have 2 roots. So I'd get -20x equals positive 10, divide by -20, x equals -1/2, and then x equals 0, and 3x plus 2 equals 0. So 3x equals -2, and x equals -2/3. So I have -2/3, -1/2, and 0. So this is why that outer inner doesn't always work, right? When there's 3, it messes it up big time. I want to plug in points. So give me something less than -2/3. Don't make it a fraction, make it easy. -1. Okay, something in between -2/3 and -1/2 is not fun, right? But neither is -1/2 and 0. So let's try that. -1/4 can go there, right? At least I know that's in between. And then something bigger than 0, like 1. In my opinion, enough is there that you should be able to get your pattern, that you don't need to plug in between -2/3 and -1/2. But if you did, obviously you'd have to figure out a fraction that falls in between them, give them the like denominator, figure out which one it is. Yeah.
Why didn't you like multiply?
Good morning.
Like x to, you can multiply 3x plus 2 times x. Don't you can multiply x times 3x plus 2?
I am by giving it that denominator. So I didn't write that step out, but technically you are by putting it over that denominator.
Don't you do it to both sides?
What do you mean to both sides?
Like,
Both the top and the bottom?
if, like if it, like these common denominator is like x times 3x plus 2, don't you to like multiply like x to 3x plus 2 and then do it to get x also?
Yeah, I'm technically doing that by this, and this is what you're saying?
Yeah.
I'm technically doing that by putting them both over that denominator. I just skipped that step. But you are doing that because you're saying those are both over that denominator. So if you want to see that step in between, it's negative 5 over 3x plus 2 would equal what over x times 3x plus 2, right? And we would multiply this by x, and I get negative 5x. This takes the place of that first fraction. Does that make sense? Is that what you're asking?
Yeah.
Yeah, so then I did the same thing for 5 over x. I made it something over x times 3x plus 2, which I'd have to multiply by 3x plus 2. I distributed the negative here, so I got negative 15x minus 10. It's just that I'm writing this all over one denominator instead of writing it twice. Does that make sense?
Yeah.
Okay, I just kind of skipped that step, but that's what you are doing. Yeah. Okay, so now I'm plugging into here, right? So what am I on, 5? Okay, so let's plug in negative 1. And you can plug it into the beginning. You can plug it into once you move the 0. It doesn't matter where. Audrey, you have a question?
When we're done this, I have to go back to 4 because I was doing 5 while you were doing 4 and I got really confused.
Okay, next time stop me. I asked if we're good.
Well, no,
You gotta
because I
stop
thought I
me.
was doing 4 the whole time and then I looked
Oh.
and I was doing 5 because I got all fractions. I was like, wait a minute.
This is,
Yeah.
nope, greater than.
That was not very fun.
So I'm just doing the outer two for right now. Negative 5, negative 3 plus 2, negative 5 over negative 1. And that's 5 is greater than or equal to negative 5, which is true. That part works. If I do the right side, negative 5, 3 plus 2, negative 5 over 5, negative 1 greater than or equal to 5, that does not work. So if my pattern is every other grouping, then this is consistent with saying it works for this one, it won't work for here, it works for this one, and then it didn't work for the one on the right.
How do you know that it's every other?
It's usually, the only time it's not every other is if you have like a duplicate root. Like the same number comes twice. So it's always been every other, yeah. So now I would say, because it's or equal to, right, in the beginning, neither those roots can be equal, which gets the bracket, which means if I look at the fraction on the left, negative 2/3 has to get a parentheses. The fraction on the right, 0, has to get a parentheses. So everything that made my original equation have a 0 in the denominator has to change from bracket to parentheses. So now I know that 2/3 has to get a parentheses, arrow to the left. 1/2, negative 1/2 is fine, that gets a bracket. But 0 gets a parentheses, shaded in between. So negative infinity to negative 2/3, parentheses, union, bracket, negative 1/2 to 0, parentheses.
The infinity always gets a.
Parentheses. Infinity always has a parentheses because it's not a number we can include.
The thing on the 0, that's in parentheses, right?
The thing on the 0 is a parentheses. Yep. Yeah, because the initial equation had an x in the bottom, which would mean x can't equal 0.
So it's every other one unless it's a duplicate root or unless it's a duplicate root
Correct.
or specifically an and or always.
Like an all real numbers one, you mean?
Yeah.
Yes, correct.
Or like if it's an and or because then it's like that. And it's only like
Even
one
if it's an
number.
or and it's pointing out, you're saying this works, this one doesn't, this works, so it is every other.
Oh yeah, true.
Yeah.
And for an answer, but it's always every other.
Yep. Unless I literally get the answer like negative 2 twice, then obviously it messes that up.
Because I got an answer on the homework where like there was 0 twice. I didn't get the answer 0, just obviously I only got the answer 0. I got the answer 0 once, but I wrote it twice because it said right twice.
Did you get like an x squared? Oh,
I
okay.
don't know why it had your answer, but that was. Oh,
Okay.
I have a question for 4.
Okay. Okay, let's look at number 6. So again, we've got to get both fractions to the same side. So 1 over x minus 3 minus 3 over 2x plus 1 is less than or equal to 0. Like denominator here would be x minus 3 and 2x plus 1. So the first one's missing the 2x plus 1, and the second one's missing the x minus 3. I'd get 2x plus 1. The minus can go with the 3 and then get distributed to both. So negative 3x plus 9 all over x minus 3 and 2x plus 1. Combine my like terms in my numerator, negative x plus 10, x minus 3, 2x plus 1, less than or equal to 0. Set up my test points. So negative x plus 10 equals 0, x minus 3 equals 0, 2x plus 1 equals 0, and I get 10 equals x equals 3, 2x equals negative 1, and x equals negative 1/2. So now I can plug in something that is less than negative 1. All right, last one. So this one is not set equal to 0. We want to subtract it. So 2x minus 7 over x minus 5 less than, or minus 3 is less than or equal to 0. We need the same denominator. So this over 1 would have to get multiplied by x minus 5. 2x minus 7 minus 3 times x, negative x, minus 3 times negative 5, positive 15, all over x minus 5. Less than or equal to 0. Numerator, combine my like terms, negative x plus 8 over x minus 5. Again, less than or equal to 0. So split and solve it here. X plus 8, negative x plus 8 equals 0, and x minus 5 equals 0. And I get 8 equals x equals 5. So there's my test points. 5, 8. I want to plug in something left of 5, in between, and then bigger than 8, and I can do it in the original or once I shifted it over, which is a little bit more simple here, so let's just try it there. I'd get negative 0 plus 8 over 0 minus 5, positive 8 over negative 5, and that is less than or equal to 0, so that one works. Plug in 6, negative 6 plus 8 over 6 minus 5, 2 over 1, that is not less than or equal to 0. So we assume the 9 is going to work. Also, negative 9 plus 8 over 9 minus 5, negative 1 over 4 is less than or equal to 0. This has a denominator, and it's less than or equal to, so actually I want to get to here. Less than or equal to cannot equal 0, or x minus 5 cannot equal 0, which means x cannot equal 5. So that 5 is going to have a parentheses on it, and the 8 a bracket. So I'd get negative infinity to 5, parentheses, union, bracket on the 8 to positive infinity, and there's my final interval notation. All right, that wraps up the lesson for today. Have a great day.